Hi, so this lesson is supposed to follow the PhET simulation for Molarity, the virtual lab. You should have already gone through that lab. This should look familiar to you, and hopefully after that you have an idea of how solute amount and solution volume affects the overall concentration or the molarity. And you have some idea of what solute and solution is. But let's go through some of those and we'll go through how to calculate for molarity or concentration. So a review of what is it? Well, it's how much stuff you dissolve into amount of solution. So if you think about making sugar water, you put sugar in the water. The water is going to be considered the solvent, and that's typically a liquid. The sugar you put in a lot of times will be solid particles. That's called the solute. Sometimes a solute can be also in a liquid state, but usually it's going to be in a solid state particles. That's going to be our solute. So once you put your solute, your sugar, into the solvent, that's the water, together the two, when they mix, we create something called a solution. And what molarity is, or how the formula for it, is moles of solute, that's how much stuff you have, divided by liters of solution. So essentially what you want to think about is what molarity tells us is how much stuff do we have packed into amount of solution. Okay, so if you look at this, if you have something that's a high molarity, you would have a lot of solute, a lot of particles packed into a very little bit of space. That's considered high molarity. If you have low molarity, okay, there's low molarity, that's very little amount of stuff, very little bits of solute packed into a greater amount of space. Okay, that's what low molarity and high molarity are like. And you'll notice some dots. The pink dot will always refer to moles of solute, and then the yellow dot will always refer to moles of solution going forward. And so it's actually pretty easy to solve for molarity. And the easiest thing I could do is if I give you a question where moles and liters of solution are already given to you. So let's look at problem A. What is the molarity of 2.0 moles of sodium chloride? That's supposed to be a dot right there. And that 2.0 moles of sodium chloride is going to be in 1.5 liters of solution. So if you look at the formula, if you want to calculate for molarity, meaning if we want to calculate for the concentration, you take the moles of solute, our 2.0 moles of solute that goes on top. You're going to divide that by liters of solution. We have 1.5 liters of solution, so that goes on the bottom. So 2 divided by 1.5 gives us 1.33 molar. So that means for every 1 liter of solution, we have 1.33 moles of sodium chloride packed inside that liter. Here's another example. Problem B. What is the molarity of 0.45 moles of sodium chloride in 1.8 liters of solution? Again, there's my moles. That goes on the top of our formula. There's my liters of solution. That goes on the bottom of the formula. So 0.45 divided by 1.8, that gives us 0.25 molar. So that means there's 0.25 moles of sodium chloride dissolved in every liter of solution. Notice I say molar, I don't say molarity. So you can either refer to this right here as 0.25 molar, or if you're writing it down, 0.25 m. We don't say 0.25 molarity. That's not how we say or express concentration. Okay, so those are the units for concentration. Capital M, or if you're saying it, it's going to be molar. All right, so if you compare these two, you can actually look at the values and figure out which of the two solutions, A or B, is more concentrated. More concentrated just means in which solution do we have more moles packed into a given amount of space. Okay, so if you think about if I have a classroom full of students and I want to make the classroom more packed with students, I'm going to jam in more students into that room. that's going to be more concentrated. If I want to have a lower concentration of students, well, then I'm going to have to remove students from that room. Okay, so if you look at the values, 1.33, let me move my screen, 1.33 moles per liter, it's a lot more moles per liter than 0.25 moles per liter. So this is more moles per liter packed into that, more solute packed into that liter. And this is only 0.25 moles per liter. So this is less solute packed into that liter of solution. Okay, so we're going to refer to this one as a more concentrated solution, and this one will be our more dilute solution. That just means less concentrated. Okay, so the higher value, the higher molarity is going to be more concentrated. The lower molarity will be less concentrated. Okay, and that's probably the only type of problem I'm going to ask you to do at this point. Again, if you have questions, you can always email me or join for tutoring. Thanks. Bye-bye.